Here we are going to review adding, subtracting, multiplying, and dividing fractions. So this first one says 3/2 minus a negative 9/5. Now every time we see minus a negative, that actually means plus a positive. So whenever I add or subtract fractions, the number in the denominator has to be the same. It's like adding or subtracting like terms. In order for fractions to be like terms, the numbers in the denominator must be the exact same. Here they are not, so we need to change that to make them the same. So this 2 and 5, a common number between 2 and 5 would be 10. That means I need to multiply this 2 by 5. What I do to the bottom of a fraction, I have to do to the top. See how I'm putting these little dots? Those little dots means multiplication. So here, to change this 5 to a 10, I multiply by 2. Again, what I do to the bottom of a fraction, I do to the top of a fraction. And I get 15 over 10 plus 18 over 10. And now when I add or subtract, since the denominator is my like terms, I keep it the same. So the 10 stays in the denominator. And then 15 plus 13 or plus 18 gives me 33. And I get 33 over 10. Very important right here. I want to keep fractions improper. Keep fractions improper in this class if they show up improper, unless the directions ask you to round to the nearest tenth or hundredth, whatever. So down here, subtracting a negative, which is what we did right here, means the same thing as, notice we changed subtracting a negative is the same thing as adding a positive number. Minus a negative means plus a positive. So, in order to add or subtract fractions, what must be true about their denominators, the number at the bottom of the fraction? So, you'll need to write this down. They must have a common denominator. That means the same number in the bottom of the fraction. Both of them must be the same. So here I have 2, I have 4, I am adding these fractions here. My denominators are not the same, so I do not have like terms. Therefore, I need to make them the same. I'm going to rewrite this a little bit bigger. I can change this 2 to be a 4. I don't have to multiply both of them all the time. Sometimes you only have to multiply one fraction. So here I'm going to multiply this by 2 because that'll give me a 4, which is what is in the other denominator. But again, what I do to the bottom, I must do to the top. So I get 2 over 4 after multiplying that first fraction by 2, plus 7 over 4. Again, when I'm adding like terms, my numbers in the denominator stays the same. And then 2 plus 7 is 9. 9 over 4 cannot reduce anymore, and I'm leaving it improper. Same thing goes with subtracting. I need a common denominator. But here, I have just a whole number, 2 minus 1/5. I want to change everything to be the exact same. So I'm going to say 2 over 1 minus 1 over 5. And I want to know what that equals. So again, I need to have common denominators, which I currently don't. So I need to make them common. I do that by multiplying the numerator and denominator by 5. And I have 10 over 5 minus 1 over 5. Now, these are the same. When adding or subtracting, you keep the denominator the same. 10 minus 1 gives me 9, again, keeping it improper, and that is completely reduced. So here we go again. I see that I have a integer. I am going to make it into a fraction. I just put it over 1. Whenever you have integers, it makes it easy to determine what a common denominator is, because the denominator of any integer is 1. So in order to change my integer, I just multiply this by 7. What I do to the denominator, I do to the numerator. So that gives me negative 7 divided by 7 minus 5 over 7. This is where it gets tricky. Negative 7 over 7 minus 5 over 7. Again, I have common denominators now, so that number will stay the same in the denominator. But in the top, I have a negative 7 minus 5. The negative numbers get tricky. You can use your calculator in this class. You can use it for anything. So here I have negative 7 minus 5, which is negative 12 over 7. I leave it improper, and that is completely reduced. Now I'm getting into dividing fractions. So there's a little trick when we divide fractions. You do not need common denominators when multiplying or dividing fractions. You do not need that. So I have 5 over 9, but when I divide fractions, instead of dividing, you multiply by the fraction's reciprocal. Reciprocal means to flip the fraction. So negative 8/5 is the same thing, or we multiply that as negative 5/8. So very key here. When dividing fractions, we multiply by its reciprocal. Now 5 times negative 5 gives me negative 25. And 9 times 8 gives me 72. When we multiply, you just go straight across. Numerator times numerator, denominator times denominator. This fraction is completely reduced, so there's my final answer. Again, when you divide fractions, you actually multiply by the reciprocal. So dividing fractions means to multiply by the reciprocal. The reciprocal means to flip the fraction. What does the dot mean in math? That dot means to multiply. The reason why we use a dot, you're used to seeing this x as multiplication. Well, we are going to do a lot with variables in this class. And x is a variable that comes up a lot. So to distinguish whether we're talking about a variable or multiplication, we'll just use the dot for multiplication. So 3 times 2 would equal 6. So that dot means to multiply. So that's what we're going to use when we multiply. So do you need a common denominator to multiply fractions? That is false. We only need a common denominator when adding or subtracting fractions. When multiplying or dividing fractions, you do not. So here I'm dividing. Again, when you divide fractions, that means to multiply by its reciprocal. The reciprocal means to flip it. So now there is a little trick we can do here that I'll show you in a minute. So 4 times 7, again, we multiply straight across. So 4 times 7 is 28 over 56. This can reduce to 1/2. How we reduce fractions is we say, well, we did 7 times 4 to get 28, and we did 7 times 8 to get 56. 7 divided by 7 cancels, leaving me with 4 over 8. Well, 4 can be rewritten as 2 times 2. 8 can be rewritten as 2 times 4. Those cancel. Those 2's are both on the numerator and the denominator. They cancel. 2 can be rewritten as 1 times 2. 4 can be written as 2 times 2. Those 2's cancel, leaving me with 1/2 as my fraction. You could have seen that at the beginning. I see there's a 7 on top and on bottom. And I can take a 4 and leave a 1, take a 4 and leave a 2. That leaves me with 1/2. That is a quick trick to reduce a fraction when multiplying or dividing fractions. But this way works just fine. When multiplying fractions, we go straight across. Whenever you see a negative in front of a fraction like this, just put it with the numerator. So really you can say negative 14 over 9 times 3 over 2, and we multiply straight across. So negative 14 times 3 gives me negative 42. And then 9 times 2 gives me 18. Now we can reduce this fraction. So this fraction will reduce to negative 7 over 3. If you can't see that right away, which most students can't, so that's okay, we need to break down these numbers. Negative 42 can be rewritten as negative 7 times 6. 18 can be rewritten as 3 times 6. I have a 6 on the top and the bottom, so those will cancel, leaving me with negative 7 over 3. Here, again, whenever I see a negative sign in front of a fraction, I just put it in the numerator. So I have negative 8 times a negative 3. A negative times a negative gives me a positive. 5 times 2 leaves me with 10. So here I must reduce this fraction. I know 24 can be reduced into 12 times 2. 10 can be reduced to 5 times 2. Since 2 is on top and on bottom, I cancel those out. As always, my fraction is reduced to 12/5, and I leave it improper.